This is the solution to the try in the corner problem, and I've set up an idea of the problem here. D and E are the two rugby posts, and F is the point that the player's kicking the ball from. As we move F back and forth along the touchline, we can see that the angle DFE gets bigger and then gets smaller again. That means that somewhere along that touchline there must be a maximum angle and therefore an optimal distance AF. We'll need to look at a couple of triangles. The first one is a DF, and the second one that we'll need to have a close look at is a EF. I've drawn those two triangles here and put on the necessary measurements. I've called the angle in the first triangle alpha and in the second triangle beta. Now the angle that we're trying to maximize here is theta, which is equal to beta minus alpha. Now at this stage I expected my pupils to put that formula into a spreadsheet and perhaps highlight the maximal outcome each time, gradually working to more and more decimal places, getting a more and more accurate answer. Or alternatively, they could have plotted a graph to try and find where the maximum point was. But we can also solve the problem algebraically using differentiation. We need to know that tan to the minus 1x differentiates to 1 over 1 plus x squared. When we differentiate, if we put the differential equal to 0, we can find the maximum points. Now the differentiating isn't as easy as all that. You need to use the chain rule a little bit here and there, but if you do, then eventually you'll end up with this equation. All you need to do is some algebraic mucking about to find that x comes out to be 34.89 meters.